In this lesson I show you how to use color setting. Color setting is required for band density determination in plots, spot number estimation and spot density determination in videos. Color setting is based on an RGB or red, green, blue value. Therefore, one way to express a color is by its RGB value. Red can range from 0 to 255 in the scale, and so can blue and green. All colors are based on these three colors. When R is equal G and equal B, then the color is either gray, black or white. So let's set red to 100, green to 100 and blue to 100, and we get a dark gray color. Black is 0, 0, 0 and white is 255, 255, 255. Red would be 255, 0, 0 or a value lower than 255, like for instance 100 and 0, 0. Let's see if that is true. So here we have a dark red, and if we increase that we get a light red to a pure red when it is 255. So now let's work with this image which has spots of different colors. Let's determine the RGB value of, for instance, one of the yellow spots. We check the Check RGB box and we draw a rectangle around one of the yellow spots. But before doing that, we change the line color to, for instance, blue. We get three values. A mean value, which uses all the pixels within the square, and which is 91, 91, 0 here. Then we have the precise value, which is the highest or close to the highest RGB value within the rectangle. And this is 246, 246, 0 in our example. So this shows that yellow is a mixture of red and green. Then we have the background value, which is 0, 0, 0, which stands for black. If we want to get an RGB value for the number of pixels, we need to set the RGB value lower or equal to the actual RGB value. If we leave R, G and B 0, nothing would be counted and we wouldn't get any value. So to count yellow pixels, we need to set a value for R and G and leave B 0. Spots in stained tissue sections, like using immunohistochemistry, are heterogeneous and consist of pixels of different color shades with a range of RGB values. So here we set red to 200, green to 200 and leave blue 0. Then we uncheck the Check RGB box and create a rectangle around, for example, this yellow spot. And we get a raw value which counts all the individual pixels. The number of pixels is shown, which has an RGB value higher or equal the preset value. The total area in number of pixels is shown under Area. Let's keep the preset RGB value, and now let's check a red spot. There is no value for raw and spot because this red spot has 0 green content. If we set green to 0 and check another red spot, we will get values. If we want to check the exact color, we check the exact color checkbox. Now we will not get any value for our red spot because our preset does not match the exact color. Let's examine that. The raw and spot values are 0. I know that most of the pixels in this red spot have an RGB value of 255 to 00. So we set R or red to 255. Now we measure the same spot again and we get actual raw value and a spot value. Another possibility is to measure colors only within a certain range. For example, we preset a low value of 150 for red. And we set the upper limit to 100, which means that all RGB values between 150 and 150 plus 100, that means 250, will be measured. We uncheck the exact color checkbox from the previous trial, and now we check this red spot. We get only very few pixels which have an RGB value within this particular range. So let's change the upper limit to 255, and so we set the preset value from 100 to 105. Let's look at the same red spot again. And now we get a large number of pixels which fit into this range. So by using color setting, we can exactly determine which color range we want to determine. And this concludes this lesson.